Today's example on wave says estimate the refractive index of the medium, assuming the wavelength of electromagnetic wave in the medium is 600 nanometer and the wavelength of electromagnetic wave in the material is 300 nanometer. And the second option says find the velocity of electromagnetic wave in that medium. The third one says what is the frequency of electromagnetic wave traveling through that medium. So as students, we are going to contemplate on the right expression to use. Looking at this question, we can see that the equation is emphasizing or talking about electromagnetic wave, and we should know that all electromagnetic waves travel at a particular speed, which is the speed of light, and it has the value of 3 times 10 to the power 8 meters per second. In case you see us apply the speed of light, you shouldn't be confused about that. And we have the wavelength of this electromagnetic wave traveling through the vacuum to be 600 nanometer, and the wavelength of that of the material is 300 nanometer. So we are going to pick an expression suitable to enable us solve this example solution. If we are using n, refractive index equals to lambda naught all over lambda, will help us to get the solution of the refractive index of that material. So we are going to substitute the value for the refractive index, lambda naught. We are going to substitute 600 nanometer, and lambda, we are going to substitute the value 300 nanometer. And of course, the value for nano means 10 to the power minus 9. In case you see we interpret it in our further example of the problem, you shouldn't be confused. Nano is 10 to the power minus 9. Alright, so in this case, I will not do anything because even if I convert it now, it will still cancel out. So let me move further. By substituting lambda naught, we have the value 600 nanometer all over 300 nanometer. Why I said I was not going to convert was that even if I should convert it, I will still strike these values out. So since they are the same value, it will still strike out. But as we continue, I will do a conversion later on. Okay, so let me continue. Dividing 600 nanometer by 300 nanometer, I get the value 2. So this gives us the value for the refractive index for I. Then the second option says find the velocity of electromagnetic wave in that medium. Find the velocity of electromagnetic wave in that medium. But we have the refractive index, so we have to now sit down and contemplate on the best expression to use. Looking at this, we have n equals to c over v. So the c here represents the speed of light in a vacuum, and the v is the speed of light in a material. So we already have n, and we know that the value for the speed of light in the vacuum is c, is a constant. So we are now going to find the unknown value here, which is v, the speed of light in the material. So we make v the subject, and this is our new expression. We substitute the value for the speed of light and the value for the refractive index. So if you're looking at this, you see the refractive index up here. Look at it here. This is 2. I now substitute the value here, and this is the speed of light up here. Alright, so when you simplify the two, you get the value for the speed of light in that vacuum, which is 1.5 times 10 to the power 8 meters per second. 1.5 times 10 to the power 8 meters per second. Then the last option says, what is the frequency of electromagnetic wave traveling through the medium? What is the frequency of electromagnetic wave traveling through the medium? We are using F equals to V over lambda. Remember the expression V V equals to F lambda. Okay, so if we make the frequency in this expression the subject, we have V over lambda. That's the expression we are going to use here, and we have the value for V, velocity in that medium, and we have already had the value for lambda, the velocity, the wavelength in the medium, which was given in the equation to be 300 nanometer, as you can see here. Okay, and the nano there I initially said means 10 to the power minus 9. So we are going to do the conversion and get the value, dividing this by 1.5 times 10 to the power 8. We have, look at this, the velocity of light in the medium. This one was nanometer. This nano is 10 to the power minus 9. Now this one is 300. This 300, if we convert it to standard form, our index here now reduced to minus 7. Our index here was minus 9. We have two other positive zeros here, which will affect our index, and it reduces to minus 7. If we divide the numerator by the denominator, then we have a single value for the frequency, which is 5 times 10 to the power 14 hertz. So we have come to the end of today's class. Thank you for watching, and I would like you to do us a favor by clicking on the subscription button. Have a great day.